Let me welcome you to the 35th lecture of surface mining technology. This is the 5th and final lecture of excavation with surface miner. We will solve a second tutorial here. So, in this tutorial we basically will go for cost analysis for the excavation with surface miner. So, let us have one look into the learning background of surface mining technology course. These are the learning objectives of the surface mining technology course, and these are the expected learning outcomes for surface mining technology course. These are some of the texts and references available in the market, and let us look into the previous lectures what we have covered before this topic surface excavation with surface miner. We have covered the phases of mining a deposit, we have covered commencement of surface mining using box cut, we have covered the drilling technology, we have covered the blasting technology, we have covered blast free excavation technique, that is the reaper, and we have covered the excavation of fragmented rock mass either by blasting or by reaper through a shovel or excavator. We have gone through the different types of excavators, and we have seen the transportation system, dumper transportation system, and how the dumpers are working along with the shovel, how the shovel dumper combination can be carried out, that is discussed already. And we have started discussing the excavation with surface miner, which is another blast free mining technology, continuous excavation technology, and very highly applicable technology for the current surface mining situation. And in this lectures we had the objectives to understand the application of surface miner, to understand the cutting principle of surface miner, design and method of operation of surface miner, all these are discussed. We have carried out already one tutorial for the performance analysis of the surface miner, and in this tutorial we will cover the cost calculation for the surface miner. So, this is one last class on the excavation with surface miner. So, let us directly start with a problem. In this problem, we are having a coal mine, a surface coal mine. The mine authority decided to outsource the coal excavation by surface miner for its a particular seam. So, the planned length of the bench is 2000 meter, and now contractors are asked to go for bidding, and it is considered the desired machine is 3700, which is available at a price of 6 crores, and it is comprising a cutting drum of 3.7 meter, which can cut a depth of 0.5 meter. So, now you see the depth is given in meter directly, not in centimeter. So, you have to consider that in your production formula. Cutting speed is given 25 meter per minute, diesel consumption is given at 60 liter per hour, and the subcontractor has to give the tender price in this. Further, the problem is extended, which I will not solve at this place, but it is the duty of the participants to do it back to their home. Suppose the mine authority is failed to provide the promised length of 2 kilometer pit bench length of 2 kilometer, if instead they are providing the length of 500 meter, then what is the loss to the contractor for the same and how much compensation a contractor will ask to the from the mine authority for the same. So, that calculation need to be carried out. So, it is a simple one. The first the calculation will be made considering the L is equal to 2000. So, whatever price is coming, the calculation can be made using 500 also, then find out the differences between these two, whatever is the differences, that is the compensation will be asked from the mine authority because of their inability to provide the desired length. So, again once again look into this formula, these are already given. Now, I just reduce the size of this, so that I can solve at this place. So, you have to find out the production rate and a number of data needs to be assumed. The given is the given data is V is given 25 meter per minute, the L is given 2000 meter, the S is given 3.7 meter, cutting depth D is given 0.5 meter and few data is given pertaining to cost, that price capital cost is 6 into 10 to the power 7 rupees and diesel price is given 60 rupees per liter and sorry, it is not diesel price, it is diesel consumption is given 60 diesel consumption is given 60 liter per hour. So, this is given and we have to assume a number of other data. So, for production related data, let us assume what we have assumed previously, say V e is 30 meter per minute and we have to assume the turning time 3 minutes. We have assumed the truck exchange time is 0.5 minutes, that is 30 seconds, and we have assumed the truck capacity ton. So, your LT will be calculated as 35.7, density also assume in situ density of coal also assume 1.4 ton per meter cube. So, let us assume all these things and utilizing this we can have calculations. So, our assumptions, this is given and assumptions we are showing truck capacity, this is the this is not required for this is the price of the machine, this is the life we have assumed, this is the interest, this is the maintenance cost, assumptions, peak consumption we have assumed, peak price we have assumed, diesel consumption we have assumed, sorry our that 60 liter has to be changed to 80 liter, here we have taken 80 liter, availability we have assumed 4000, material density we have assumed 1.4, and we have also assumed our truck change time, turning time, pit length, diesel price, number of persons, effective hour in a shift, overhead cost 10%, profit 10%. Then these are not required. This is cutting speed, this is average cutting depth, this is empty travel speed. So, these are the assumptions. Now, based on these assumptions, first what we did? First we have calculated the production. So, we have found the length to cut to fill a truck. Actually, there is some problem with this. Let us, probably it is a little bit mistakes occurred here. So, the procedure will be remain same. So, our length truck capacity is this much. Oh, sorry, this is actually carried out, our cutting drum width is changed. So, that is why truck capacity So, the truck capacity is 20 ton, material density is 1.4. So, it is coming around 14 point something meter cube. Now, this for achieving this meter cube, our length required is 14 divided by 3.7 into 0.5. So, that is why this is coming close to 7 meter. So, 7.72 meter is coming the length of cut required to fill a truck. So, the time required to fill a truck is now 7.72 divided by cutting speed is 25. So, whatever is coming, that is the time required for cutting the filling a truck, that is 0.31 minute. In every 31 minute you are able to fill the truck if you are going for conveyor loading. So, the production ton per hour you have to calculate, not this one, for different methods you use the formula and all the desired component which we have assumed. For that, windrow empty travel mode, it is coming this one, windrowing continuous mode this one, windrowing turn back mode this one, conveyor loading empty travel back mode, conveyor loading continuous mode and conveyor loading turn back mode. These are the options achieved. So, considering this, we have to find out, these are the production target, how many number of machines are required, considering 1 million ton is found here, but our requirement is that we need to find out the costing. So, we have to consider different cost components. As it is known, our first component is capital cost. So, as we assumed, capital cost is the capital by life. So, this is 6 into 10 to the power 7 divided by 30 into 10 to the power 3. So, the capital cost is coming something. So, this is 10 to the power 3. So, this is 2 into 10 to the power 3. So, that is 2000 rupees per hour. So, all are in rupees per hour, and we are considering interest is 10% of the capital cost. So, we are considering interest is 200 rupees as it is given here. Maintenance cost is 20% of the capital cost. So, maintenance cost, these are the assumptions we have made. So, that is 400 rupees per hour. So, this is the multiplying. Then we are considering diesel consumption. So, that is a little bit deviation from the problem. So, we have considered 80 liter here. So, diesel consumption is 80, we have considered the diesel price is 90 rupees. So, 7200 is the diesel consumption per hour. We have considered the peak consumption also. So, we have considered peak consumption per hour is 1 and peak price is rupees 2000. So, peak consumption is 2000 rupees per hour, and we have considered the manpower is 2. Let us look into the considerations. So, number of person is 2. We have forgot to write the or EMS is given. So, I think manpower cost is two and EMS is 4000, and we have considered operating shift. Operating shift is 5. So, operating shift is 5. So, that is 1600 rupees. I think is there any deviation from that? Let me check. 1600 rupees. So, that is so this is the manpower cost. This is manpower, this is diesel, and our fifth component is peak consumption, which is this is peak consumption, sorry, this is peak consumption, which is considered here. So, this is peak consumption, this is manpower, and then we are having a subtotal. So, let us add it. So, it is coming 0. So, this is the hourly cost, and we are adding to this 10%, that means 1300 to the overhead. So, 1340. So, this is 40, this is 7, this is 4, this is 1, then 10% profit. So, 1474. So, it is coming 4, 1, 2, 6, 1. So, this is coming close to this. So, in considering with that, we are finding that owning cost is 2000 rupees, interest maintenance cost peak cost rupees 2000, diesel cost this one, manpower cost this, overhead profit. So, altogether the total cost is coming close by adding up all this, and this is the total cost. Now, we have seen our production. Production from each method is shown here, production per hour. So, as these are available with this, if you are divided your rupees by this production, you will get the mining cost in rupees per, sorry, you have not considered this is in ton, this is actually in meter cube, in rupees per meter cube. This is not in ton, this is in meter cube. So, it will be considered in rupees per meter cube. So, in doing so, you will find this is the rupees per meter cube. So, make the corrections here. So, these are the values obtained, and it can be seen the minimum cost is windrowing continuous mode, windrowing turn back mode, and maximum is obviously continuous empty travel back mode. This is for 2000 meter pit length. So, the things will be altered. If you do the practice for 500 meter, you can check whatever will be the change in the cost. Obviously, it will not change in these two, because these are not dependent on the length, but it will change for the others. Now, in this case, this part is important, but though one can see that this part is significantly lower than this part, but this part is essentially having the next component, that is the FEL loading system. This FEL loading system has to be considered. What is the cost coming for this? What is the cost coming for this? That has to be added along with this to compare between this one and this one. So, whenever a subcontractor has to calculate its costing, either he has to consider windrow plus loading plus transportation. Let me write once again, windrowing plus loading plus transportation, or he has to consider conveyor loading plus transportation. So, if the transportation cost is same for this one, so basically windrowing plus loading, and you have to compare between the windrowing and loading and with the conveyor loading. So, that is why this part plus the loading must be considered to compare this with this system. Okay. So, this is the essential requirement. I leave that 500 meter calculation part at your end. There may be some printing mistakes, consider these are as meter cube, the same thing is there for the previous one also, that has to be considered here. Now, let us look into some similar calculations. This is for a limestone, comparison of the cost calculation for the limestone and coal, and these are the different components, and you can see the cost is coming around 74 rupees per ton. Here we multiplied it with the density to make it ton, and here it is 35 rupees per ton is coming for the coal, and these are the different components, lubricant, peaks, all these are considered here. And I hope with this we are concluding with the excavation with surface miner. This chapter we are concluding here, and it is expected that more and more tutorial will be practiced at as the home assignment at your end. Thank you.